I'm happy to introduce Dr. Asmare Dejen. He is from Wollo University, and he's working on. He's also working at the Ethiopian at the Amara Agricultural Research Institute. Dr. Endale is working for the Ethiopian Public Health Institute. So we are happy to bring our work and summarize it here. Am I being heard? Yeah, okay.
Go ahead.
Okay. Okay, thank you. I don't know where to stand, but we have a major title, and then we have subtitles, each of us. We will see them later. Next one, please. Yeah, we start with a problem. There are research components.
Would you like to click your own?
Yeah.
That one's forward.
Okay. Research components. We have 3 research components: agronomy, ethnobotany, nutrition. We are addressing grain mixtures and the anticipated outcomes or interconnected outcomes are those listed over there. Addis Ababa University deals with the ethnobotany. Wollo University deals with agronomy, and then Public Health Institute deals with nutrition. So this is my topic, wisdom of smallholder farmers on traditional grain mixtures. I have 4 short points to consider my title. First of all, short introduction. Topographically, Ethiopia is very diverse, widespread, and major vegetation types are there, microenvironments are there, agricultural landscapes are several, and the diversity and variability in agroecology, crop species, varieties, land. It's the land of ancient grains and ancient agriculture. It's a place of cultural diversity. And one of Vavilov's 8 centers of crop origin. So we see that we are working in a high crop diversity area, that is Ethiopia, and high grain crop diversity also in northern Ethiopia. And South Wollo, where we are working, is the heart of the grain-based agroecosystem. The target crops are major grain crops: sorghum, teff, wheat and barley, faba bean, and field pea. We are dealing with the mixtures of these crops. 2 of them are crop mixtures, and 2 of them are variety mixtures. However, even though we have these mixtures, there are challenges facing Ethiopian agriculture as a whole. Land use, land cover changes, land degradation, loss of soil, loss of diversity, decline of indigenous and local knowledge, climate change, agroecosystem change, food system, food and nutrition insecurity. There are some observations, but these observations, important farming and food system, this originates from polyculture farming, which is very common in Ethiopia, and improved agrobiodiversity, soil fertility, grain yield. They are so important. However, we don't have quantified data. We don't have quantified data. Continuity of the practice is at stake, so we need scientific data, and then the traditional grain mixture project has been initiated to address this one. The research focuses on those important points to see the merits of the farming system, the grain mixtures, and the key benefits of the mixtures. And the key questions are to see, is there any future What does it contribute to? And are mixtures and cropping systems worth researching, maintaining, or restoring or enhancing? Could the pressure on traditional grain mixtures be relaxed? Are there science-based options for restoration and enhancement? Are there strong arguments for this? Then it is time to look inwards and stride forward for innovative solutions. We are trying to find out if there are some innovative solutions out of what exists there. The crops, the materials and methods tells us that we want to assess the abundance, distribution, study ILK, and map out opportunities and constraints and explore plausible visions or future directions. And the crops are, the mixtures that we are addressing are given there. Study area, this is in 2 administrative regions and 6 districts, 18 sub-districts, and so on. So agroecologists are also different. We have 3 agroecologists. We are doing the research around there. We use the standard ethnobotanical methods. These are well known by many for data collection, for data analysis, and we have the numbers of so we have a structured interview, semi-structured interview, focus group, and all others. We have used several others. Regarding the results, there are so many crops that are grown there, but the ones that came up very well are 50 different cereals, pulses, oil crops, fruits, vegetables, spice, and so on. Crops most frequently listed are sorghum, teff, wheat, barley and faba bean, wheat and barley and faba bean and faba bean and they are from highlands, faba bean and field pea from highlands, and sorghum and teff are mostly lowland and midlands. All 4 target mixtures were grown by farmers into 2023 when we did the research. Graduate students are doing this research. Data were collected by graduate students, and these are the crops, just to show what the crops are. The results, we show some of the results. Farmers' response about mixture cultivation and use. The total number of farmers is shown in that column, and 85%, 57% and 100% of those 2 crops, people knew about mixtures. Whether they believe mixtures are declining or not, 85% say they're declining. We have a missing data there, 15% for sorghum and 32% for teff. Cultivated, in 2003, only 7% cultivated for wheat and barley, and 10% for faba bean and field pea. 91% were cultivating for sorghum, and the other 53%. So farmers' reaction to growing grain reasons for growing grain mixtures are variable reasons, but some are common. These are common: optimizing land use, lowering chances of crop failure, controlling pests, and these are major reasons. So we want to say that working around agriculture, biodiversity, knowledge, food and knowledge are important locally, also nationally, and globally as well, because if biodiversity is there, then the global community will be beneficiaries. Farmers' perspectives of major factors threatening mixtures, also results have come up from the different mixtures, and some of these results are similar, but there are also differences. Now, a little bit of results for one crop, at least, sorghum, variety mixtures. You can see that there are different varieties, about 21 varieties Sorghum mixtures included 21 varieties. Most farmers manage and use mixtures, less bird damage, better yield, desired grain qualities, and more use values. Seed sources, healthy panicles are selected and used as seed from own farm. Then persistent constraints are there. Birds, climate, disease, insects, worms, and so on. And so you see, birds are very difficult to manage. So therefore, people have improvised something. Yeah. Okay. The varieties range, I mean, show from some of them range from lowland to highland. Some of them they are common in lowlands and this way in districts as well as in qabales like that. Okay, yeah. So if you see one of those, you see some are lower in the lower part, I mean lower altitude, and they are more in the higher altitude, and some of them are going in the reverse way, and some of them are spread very well. So some are abundant in high altitudes and rare at low altitude. Some are abundant at, for the other three crops, we have done similar things. Thank you very much. I call upon my colleague, Dr. Asmara, to.
Thank you very much. I think the audience are, I suspect that they are agriculturalists, so they can understand us easily. We formulate this presentation that the introduction part is covered by Professor Zemede, and then the material part is for his own, for his own. So I do not have introduction part because it's already said. And the conclusion and the forward is the way forward is covered by Dr. Endale because it's the last speaker. So this is my title. Actually, this research is done by 4 MSc students, so we do not cover all, but we'll cover only 2 crops. One is a species mixture, and the other is on varietal mixture. So the objective of the study was investigate the advantage of grain mixtures in terms of yield, drought resistance, pest and disease management, and also to determine the mixture, that is a ratio of this mixture, because they mix and we want to know the proportion. So this is these are the material, because this is an experimental, well-designed one. So we have material emitters. We are collecting more than 60 variables, but I will present, few of them. So the material, we are selecting the site, data collection, data analysis, and finally, students write the report. We have used the model mother and baby trail. If the mother and baby trail has different characteristics. One is the mother trail managed by the researcher on station, and various you collect different data variables. But in the baby trails, it's managed by the farmers, and also the treatments are very few to avoid the confusion of the farmers to gather information. That's the perception of the farmers on different mixtures. You use in mother trails about 8 treatments, replicated 3 times in different areas. Professor Zemede mentioned the areas, the districts that we are working on. These are the treatment arrangements for mother trails and also baby trails. Very few treatments to the farmers to measure their perception. The result, I will start with sorghum. that there are different agronomic variables that you measure. Stress, these are the flowering period, and the other is maturing period. So the maturity or the physiological period. So we can see these are the sites and the period that the flower period that took. So most of the maturity period is the flowering period is shorter in Waladi and in this side, Degan, whereas Ajari longer. Uh, and also that treatment or that tables also shows the different mixtures. So the longer is in Mokake and the shortest is the sol intermediate type, and it is high proportion. As this is a maturity, the physiological period, also the physiological maturity, you can see here, the high is the longest is in Mokake, this variety, and the lowest is in Sol Jigurti, and it is high proportion. So and with regard to the mixture in stalk borer, that is the major insect pest is attacking on sorghum, we can see the susceptible, high susceptible variety for this mixture is this one, this is the yellow seeded one, that is Mokake, but the mixture and the red one, that is the intermediate type of the mixture is low incidence in both areas except this area, this Waladi areas, because it's a host very, very, highly infested areas of the insects. So 100% of the incidence occurred in this area. That is the incidence. Actually, if you see some a symptom, a single symptom, you count as it's damage. But wherever when we see the severity that cause damage on grain, so the highest is in Mokake, in this variety, and the lowest is in this one, and the mixtures. When the proportion of Mokake is high, the damage, the severity is high. So, mixing the crop reduce the stalk borer. This is the striga, the parasitic weed also affect, if we measure the effect in the soil, high pressure on this soil varieties, but reduce drastically reduce the number of striga. Whereas the same trend is shown on grain yield. We can see here in the smile at Degan, high yield on this intermediate type, but in the long maturing variety, low yield. And when we mix, they give a better yield as compared with this Mokake, and a yield advantage of 70% over Mokake is gained. So mixing the two crops is better than the sole one. This is also shown at different location, actually at Jari and Waladi. Farmers' perception was measured using these questions. So based on this, the number of farmers choose this Sol Mokake, the Sol Smile, because this area is stressed by moisture. So the long maturing variety produce less yield, and the intermediate gave reasonable yield, so that I think the biological yield and the farmer perception correlated in this way. So same is true at Dawa, Jaffa, and other site in Jari. The wheat barley mixture, actually, the yield, we measure the two diseases, yellow rust and subtorial. This barley is highly susceptible with this disease, yellow rust. The soil one is, you can see the damage, whereas the mixture reduced drastically, and then the high proportion of barley is very high. And also we can see in leaf rust and subtorial. Subtorial, you know, the wheat is susceptible on subtorial type of fungi, but it's not the occurred in barley, so that this disease, the barley is used as a barrier that cannot, you know, move or disseminated to wheat, so that it's easily, you know, protect the wheat. So reduce the infestation is also here. And you can see the yield also, yield advantage of mixing the two crops give up to 40% over, for instance, at market, this is the site, up to 40% yield advantage, and at Dese, 31% yield advantage, and at Warla, about 40% yield advantage. Actually, we have a lot of data, but within these 2 minutes, we can't present all. That's all I have. Thank you very much.
Thank you all, and thank you, Alison, for this invitation. And I also would like to thank the coordinators of this seminar. I'm from the Ethiopian Public Health Institute. By profession, I'm a nutritionist and food science area. So I will focus on the nutrition perspectives of traditional grain mixtures. I will start with promoting this slide. This is just my institution's anniversary will be celebrated at the end of this year, so all are invited. To start with, I have this outline where I will talk about the global and national food and nutrition situation, and the national evidence generation efforts on food composition, which is an evidence important to tackle the challenge that we are having. And again, what is periodic table of food initiative, which is an initiative relevant to provide evidence in this area. And of course, the last talk will be on traditional grain mixture from the nutrition lens, and finally, the way forward of all these components of the project will be discussed. So coming to the general idea about food and nutrition security, as you all know, the global hunger statistics is showing us that it's since 2005, this is a figure that's showing us a decline until 2019, where, until the pandemic erupts. After that, there seems an increment. And this is, in fact, the prevalence of undernutrition, which is an estimate of the proportion of the population whose habitual food consumption is insufficient to provide the dietary energy levels that are required to maintain a normal and active life. In fact, you can estimate, or you can translate into the micronutrient deficiency, which could be very high compared to the energy requirements. And then, well, the prevalence is 9.2 in terms of the actual figures. Again, when you look at the regional figures, Africa is carrying the huge burden, which is about 20% of the population is under chronic undernourishment. And if you look at, again, the SDG target, the global community is trying to end hunger in 2030, but a projection is showing that we are not meeting that target in 2060. I mean, in 2030, sorry. So 600 million people will be chronically undernourished in this year. So there needs a serious intervention in this area by the global community. When we look at our national statistics, especially the childhood malnutrition, when we focus on the three components, stunting, wasting, and underweight, there is still a reduction in stunting, and all the other malnutrition indicators, but still the same thing is happening. Since COVID happens, the pandemic happens, there seems an increase in the level of stunting, wasting, as well as underweight. And the nation is trying to devise several strategies to tackle this challenge, but we're not still effective in that. And when we look at, again, the micronutrient deficiency, especially the women of reproductive age, 50% of the women of reproductive age are folate deficient, which is really a serious problem. And again, vitamin D deficiency in those target groups is also 34%. This is a recent study, in fact. So although several interventions, several guidelines and strategies were devised, still the challenge is really serious. And in terms of dietary diversity, only 8% of children who are aged under 2 consume the minimum recommended number of food groups. 5 is recommended out of the 8, and only 8% of them are meeting this requirement. When it comes to the women of reproductive age, only 7% of them are meeting the dietary diversity recommendation. Well, the nation, as I said, tried to develop several strategy documents, intervention guidelines, and all those things, but there has not been any policy document until 2018. So in 2018, a food and nutrition policy was developed, which has several, this is, of course, a legal framework that gives responsibility and accountability to all implementing sectors. So nice policy directions were there. And again, after 2 years, National Food and Nutrition Strategy was also devised or developed, where those overarching policy directions were broken into several strategic objective directions and, of course, initiative. And, of course, apart from that, the different implementing sectors were, to support the different implementing sectors, performance indicators, and also identifying all those different implementing sectors were also made in this strategic document, which is really important to tackle the challenge that we are facing. And as part of generating an evidence, in fact, the Ethiopian Public Health Institute, the former Ethiopian Nutrition Institute, started generating nutrition data, food composition data, which is really a basic information to estimate intake, nutrient intake. And again, it's really relevant for the breeding practice as well, to identify best crops and food items. And again, it's also relevant to establish food-based dietary guideline. All these significance are there when we have quality food composition data. So the initiative started in 1968, and since then, up to 1998, 4 food composition tables were developed. And the breadth and depth of the food components developed in all these food composition tables were totally different. And this can be related with the nutritional information, the diversity of the foods available, and other factors could be raised. And then recently, I can say recently, since 2019, we started developing, updating the Ethiopian food composition table, where we're trying to collect several samples from the different parts of the country, several regions, almost 10 regions were addressed to collect different types of foods. And majority of these food items were plant-based ones, as you can see in this figure. So we try to identify some of those priority crops, particularly those indigenous foods where we cannot get data from other sources. Unless it is generated in Ethiopia, you cannot find it because the crops are existing in Ethiopia. So from the cereals, this is a typical teff-based injera, which is a fermented product. And we have different legumes as well as indigenous root tubers where we generated data for different data for these food items. And then apart from this, based on the primary data that we generated for those ingredients, I can say, indigenous resources, we try to develop food recipes. About 150 food recipes were collected where you can standardize the processing, the ingredient information, and all those things. Finally, we try to calculate the nutrient content of these recipes. And these are some of the parameters that we addressed. As you can see in this slide, in terms of the breadth of the parameter is totally different than you saw it in the previous slide or in the previous versions of the food composition table. Still, the components are not well addressed. There are several components left behind to be addressed. And PTFI is coming on board with a mission to map the biomolecular composition of the world food supply and edible biodiversity as a global public good, where there are several omics techniques and again data generation pipelines as well as capacity building efforts to develop detailed food composition data. You can explore over 2,000 biomolecules in a food. I mean, the breadth is very high. So these are some of the omics techniques that will be standardized or developed. And there are several centers of excellence, almost 9 centers of excellence identified throughout the globe. And Ethiopian Public Health Institute is one representing the East and Central Africa. And coming to the components that should be addressed with the traditional grain mixture is just from the lens of the nutrition. So the objective is, as you can see, so this is already presented by the previous speaker on the agronomy, that is experimental part, and we try to collect, I'm trying to show only one of the treatment, that is wheat barley mixture. So in this case, we collected about 40 mother trial samples and 72 baby trial samples. And again, for the sorghum, 42 mother trial as well as 60 baby trial samples. And for the teff variety, for the teff mixture, 24 mother trial as well as 45 barley trial. The sample size is reduced in this case because we cannot separate the grains, because this is very tiny grain, you cannot separate for the analysis, but for the others you can do that. So a separate analysis for the sorghum, for fava bean field pea and wheat barley was possible, but for this one it was not possible. So the mixture was analyzed. And these are for the fava bean field pea trial. And these are the very few selected parameters we considered for analysis. Not all were done, so it's on process actually. To show you some preliminary data on the wheat barley mixture, this is for the mother trial. In fact, you can see that this is ash data for the different treatments. You can see a slight variability among the different treatments and across the location. But we can translate this into the yield terms, because this is a comparison between the different grains. When you translate the nutrition content into a yield terms, which is the ash content in terms of hectare basis or plot basis, it will be meaningful when it is compared to the yield, because there is a yield advantage, as you saw in the previous presentation, when it is mixed and when it is grown in different locations. And then this is for the oxalate component, which is we don't need oxalate too much, but you can see that the treatments in the locations does have some impact on the composition. And when we see this one, the total polyphenol and flavonoids, you can see in this, particularly in this location, the level of flavonoid, especially in wheat, is somehow higher than compared to the other ones. As I mentioned earlier, it will be much more meaningful when we compare it in yield terms. For instance, the content of flavonoid harvested in this area on a per hectare basis might be meaningful. So this is immature data. I'm sorry for that. So the baby trial can also tell us the same thing. For the interest of time, I will rush and go to the conclusion section. As a key message, we have key message which is categorized into 3. The first one is indigenous knowledge. So in this case, the research explores the role of indigenous knowledge in shaping the traditional agricultural practices in Ethiopia, highlighting the deep understanding and wisdom accumulated over centuries. And in terms of sustainability, I think crop mixtures contribute to sustainable agriculture with long-term environmental, economic, and social benefits, including yield improvement, pest management, and of course, nutritional quality. And innovation, when it comes to innovation, traditional practices like these crop mixtures can inspire and inform agricultural innovations, promoting a more sustainable and equitable approach to agriculture. As a way forward, this is a relevant study, and as you saw, but there are lots to be done, lots left. So the first one is integrating all these data. Ethnobotany, agronomy, and nutrition is really relevant to make it very meaningful, and examining the implication of crop mixtures related to the soil health, resilience to climate variability, and nutritional yield. And of course, not only simply quantifying the parameters, the content or the composition, but also checking for the bioavailability, which may be interesting for those nutritionists. This is relevant. And inclusion of farming communities in research and development of new mixtures is essential, and advocating for participation of farmers in local decision-making and policy development process is also important. And lastly, developing policy briefs for decision makers regarding the value of crop mixtures for food and nutrition security is highly valued. So I would like to acknowledge these institutions, NYBG, for leading this project, and those three Ethiopian institutions were playing a key role, a key ground role in this project. And all these partners, CUNY, Clark, and Cornell are, collaborating on this project, and we really thank the Rockefeller Foundation for funding this project through the PTFI. And finally, which we shouldn't miss, a special acknowledgement is given to local communities and the graduate students who do the very best study and data collection process in this project. Thank you so much.
Well, that was fantastic, extremely engaging. Thank you, all of you scientists, gentlemen, for really outstanding presentations, and you did it on time. So I really am very impressed with that. I will, so we have 10 minutes for Q&A. We'll take the first question from the audience here and maybe the second, and then we'll turn to see if anyone from our online audience has any questions. And then we'll bring it back to the audience and we'll continue until time runs out. So question here from the audience or a comment that would lead to some kind of discussion. Yes.
Okay, thank you so much for the presentations. My name is Diana. I'm from Kenya. I'm just your neighbor there. It was very interesting to see. I mean, there's so much that obviously has been done in this project, and there's very little. We had very little time to present it all. But I was just wondering, in terms of now the farmers' perceptions on the grain mixtures that they're using, what is the driving factor? Is it the market, or is it the nutritional benefits? Or what is their driving force, or what is the main reason that is making them have that preference for this? And my second question is now with this information, how will that go back and feed into the policy or the strategy? There are some recommendations that you may have the government to see how you can support farmers in this, I mean, in that particular value chain. Thanks.
Yeah. The first one, the driving force. Okay.
Yeah, actually, the driving force question is very nice because farmers know why they mix, because agriculture is, the cropping system is through. Ethiopia is origin of the human being, Lucy. So from that time onward, this, agriculture is, based in that area. So mixing crop is not new for the farmers, not only in Ethiopia, for the whole world. So the driving force is one is, risk aversion, where, as you see from my presentation, in one area, the two crops were grown together, but one is failed, and then the others provide, reasonable yield because the maturity periods are different. The farmers prefer choose the long maturing variety for market and food processing and for food quality, the long one. But what is the constraint for the long one? It needs more moisture. So if they get more, if that long maturing variety gets high moisture, the farmers prefer that one. But in that area, only that early maturing variety provide yield. So they, you know, they want to grow crops for risk aversion of this climate shock. And the other is pest management. As you see from barley wheat mixture, the barley is susceptible to yellow rust, but the wheat is not susceptible. So there is no asset dissemination in science. You can support with science because a lot of studies were done. There is no dissemination of a spore, rust spore, due to that mixture because there is a tolerant variety and there is a susceptible variety. So there is no as such movement of the spore. So they get, you know, a reasonable yield. And also the nutritional aspect also is very important because in F, that is the originated, you know, the center of origin, and also the diversity is in Ethiopia. So in F, there are two types. One is white and the other red. The nutrient quality of the two is completely different. The red one has rich in iron, and the other is not. The white is less iron. So, you know, the mixture is also very important in nutritional aspect. And regarding the strategy, you know, the farmer, the government, the decision makers advocate in Africa the monotype of cropping system. That is the clustering type. But the farmers still resist because they are not participating in the decision. So we recommend in our the way forward, the farmers should, because the farmers are the responsibility, you know, to feed their family, household. So they should engage in the decision making. So in protection aspect, for instance, we do not need the monotype, the monocropping system, because if a disease comes, for instance, in wheat, there is the yellow rust, actually the stem rust, very dangerous rust. So if that happen all over you know, the field will be highly devastated and no harvest. So this type of you know, mixing type of cropping system is in parallel, you know, goes in parallel to the monotype. So the strategy is, you know, the participation of the farmers is very more important.
We needed to ask another question. Give someone else another chance. Thank you very much. What do we have online? Oh, there's no questions online. Okay, so another question from the audience? Or building on what's already been talked about?
Well, thank you for a very, very interesting and I think relevant presentation, at least from my perspective, that veers away from the line of simply pressing on with monovarietal hybrids to solve the problems of African nutrition, but actually looks back, not necessarily looks back, but looks at a more time-tested system and providing information, as you actually pointed out in the beginning, that might help us actually look in these days of climate change and in security, uncertainty, I suppose, particularly as farmers, to where we might look for answers. My question actually has to do with, it's partly been answered, but it's worth asking it again. I think that your farmers overwhelmingly seem to like, for various reasons, the use of mixtures for nutrition security, biological constraint management, etc. Yet 85% or whatever have said that they see a remarkable decline in the use of mixtures. Perhaps you could perhaps elaborate again a little bit what that reason might be, even though you alluded to it. Thank you.
Thank you. Oh, this is a good. So question is very clear. Yeah, it varies as we've seen. There are two kinds of mixtures in what we have reported here. The first group are species mixtures, wheat and barley, and faba bean and field pea. And there are also variety mixtures. So as we've seen, the variety mixtures are okay. They are in good shape, rather. So people still continue. But the crop mixtures or the species mixtures, for various reasons, they are declining. Faba bean and field pea. There are many problems that are associated with, particularly in the field, because they, I know some of the crops kind of, the right balance has to be made. Otherwise, one may also impact the other. Like the field pea can grow over and hold onto the faba bean, and then the faba bean is maybe affected. But there are also other things. When they are grown together, some problems may come, like parasitic weeds. They say that they come when they are mixed in search of one of them, or they attack one of them more than the other. And all these things show us that while they are good, while they like them, and some of them may be difficult to manage also in harvesting. The faba bean and field pea, the field pea may shatter when it dries before it is taken, or when it is harvested. So there are some problems, but overall, these problems are. But there are other sides of the problem that come also, because there is promotion of the monoculture or the high-yielding varieties, so that policy is also affecting this one, because the farmers are instructed by development agents to grow some varieties and so on. So only those farmers that really still don't want to leave may cultivate them. So we have lots of information, but what we could present here is a limited amount of that information. Yeah.
Well, it was a very rich information indeed, and I really thank you all once again for managing to get so much information shared, and thanks to those of you who are staying on a few extra minutes, and sorry for keeping you a little bit late, but we'll wrap up now, and anyone who would like to come up and ask any further questions, we'll offer 10 minutes of availability for our panel, and then after that, they're going to go to lunch with those of you who have signed up for